Hello, my name is Todd Gooch, and I'm the author of How to Draw Molecules Without Using Molecular Orbital Theory or Hybridization. Today, what I'd like to do is give a couple examples from the book. Um, First thing I'd like to do is to show standard model hydrogen. Here's hydrogen, one bonding electron. This is adequate when you want to bond something like carbon. Uh, Use your electron dot diagram to show the single bond, and shorthand is this. This is what they would have you believe is going on. But experimentally, they determined that hydrogen's bonding to two boron atoms in the molecule B10H16 and the cycloborane, such as B2H6. Uh, So this representation of hydrogen is inaccurate. Hydrogen doesn't have one bonding electron. It has two bonding sites. Key and a keyhole. Notice that this coincides with your nuclear magnetic resonance theory, that you would have a dipole hydrogen atom. And my theory is just basically saying that one side of the magnet has a bonding site, and the other side also has a bonding site, and the flow of the magnet would be this way, this right here, and this would be the negative of the magnet and the positive of the magnet. This is a bonding site, and this is a bonding site. You just don't get that with Lewis structures and the standard model. When you bond to carbon, as in the previous example, the key fits into the keyhole of carbon for the bond. And in the case of a molecule such as methane, using Gooch structures, which is what I call these in vector bonding, incorporate the vectors into the diagram. I figure I'm allowed to name them. I came up with them. I call them Gooch structures. Here's methane. It takes a little longer to draw the molecules, but you're actually getting them right for the first time. As far as I'm concerned, this is chemistry 101 for the very first time, even if you have your advanced degrees in chemistry. I'm a degreed chemical technician, but I'd say that my skills far exceed the degree at this time. These are half bonds. This is a half bond. That's what I'm calling it right now, because your single bond looks like this. Carbon. Now, I use this nomenclature because it allows me to talk with somebody that does do the standard model. If they see a single bond, a carbon-carbon single bond, then I can equate it with this. My half bonds with the hydrogens to the carbon are something new. And I would, if I was starting from scratch and making the nomenclature, I would call this a single bond, and then this a double bond, But because everybody's used to seeing this right here as a single bond, most of the time, except, of course, when it bonds to hydrogen, um, I call this a single bond. In the case of, well, I mean, you think about it just for a second before I continue on. Uh, the carbon hydrogen bonds denoted this way, and the carbon bond is denoted this way with the standard model. And obviously, these two bonds can't be the same because they're bonding to different elements. So this is a distinct advantage over the standard model to use these structures. I have a book out there, How to Draw Molecules Without Using Molecular Orbital Theory or Hybridization, and there's several reasons why I would encourage you to buy it. One, it's written by a degreed chemical technician who far exceeds his mandate as a chemical technician, and is also the author of the Gravitational Unit Theory, Unified Field Theory. Presented the work 2010, member of the American Chemical Society 2010. These are good reasons that you might want to be buying How to Draw Molecules Without Using Molecular Orbital Theory or Hybridization. It's available by the Facebook page of the same name and also on Amazon.com. If you purchase through the Facebook page, it throws an extra dollar or two in my pocket. I'd appreciate it if you would go ahead and purchase through the Facebook links. But in benzene, here's the clincher to purchase the book right here is the benzene ring. Um, Standard model Lewis structures draw benzene in this fashion with single and double bonds that alternate across the molecule. And then what they found was when they broke the bonds, that these bonds had the same energy. And so what they did was they came up with the theory of hybridizing these two structures.